great little thing we have is C sub x h y plus, do your parentheses, x plus y over 4 number of O2s. So let's pick a typical hydrocarbon here. We'll pick 2 of them to do examples. The one we did was methane, right? So CH4 was what that was written as. So this gets a little 1. The other one we were doing, let's pick ethylene, which would be C with a double bond. So 2 H's on there. That would give you a chemical formula of C2H4. So what we want to find out is how many O2s is that going to take? Well, we look at X here, so X is 1 for the first one, so we're going to put in 1. Y is 4 here, so 4 over 4. Keep that in the parentheses. That many O2s is how much it's going to take. This is 1 plus 1 is 2 O2s. So methane is going to require at least 2 O2s to combust. CH4. And what's the reason of that? Because if you only had 1 O2, it would have to go, this is confusing me now, huh? What it's going to, there's more to the formula, that's why I'm trying to simplify it, but it's not going to happen. So the rest of the formula goes on to say XCO2s plus Y over 2 H2Os. So bear with me. This is algebra, so we gotta learn a little bit algebra here to survive in the world. You think you don't need it, but you do. That's a Y. So when we looked at this here, we're going to get XCO2. So X here was 1, right? So we're going to get 1 CO2. See, I'm doing this along with you. That's why I want to verify that this equation here does work. God, I'm not good on the camera, am I? I can't fit all that in there. Get the reflection of the light off. Everything's backwards. That's why when I pull it, it goes the other way. So we're focusing here. We got 1 CO2 plus Y over 2. Y in this case was, Y for methane was 4. So 4 over 2. 4 over 2 H2Os. But remember, the reaction we're doing is CO, this carbon chain thing, hydrocarbon plus O2 makes CO2 and water. So this formula that they introduced here is supposed to work for any kind of balancing here. So what it told us here was the 2 O2s. So X over here is 1. Y is 2, so we're going to end up with 2 H2Os and 1 CO2. Is that right? 1 CO2 from 1 CH4 methane plus 2 O2s. I'm not showing all this on the screen here, are we? So is this going to work here, you think? Bear with me, this is a one-man show. Cussing more than a golfer. Content. Look at this. Good. So let me just complain now. So, here we are in the equation. That's why I said, kids, it doesn't get any more complicated than this. If you can follow this and do this, you're set forever. So does this work? 1 CO2, 2 H2Os. Let's go through and see. How many total oxygens? 2 times 2 is going to be 4. We've got 1 CO2, so that's 2 oxygens, and 2 O's from the water, that's 4 O's. We've got 1 carbon, we've got 1 carbon. We've got 4 H's, so 2 times the H2's there. It does work. Okay, that worked for methane. Let's try it now for the ethylene, C2H4. So we go and look at the formula. Let's get all this stuff out of your way here. The first portion of this we're going to do, should we erase that up there? We can leave it. So CX, we're talking C2H2. So here X is 2. So we write C2H2 plus what they're going to call X, which is 2. So put the parentheses. It's going to be 2 plus the Y portion here. Y for ethylene is 2. So 2 over 4 O2s. That's on the left side of the arrow. This is like an equation sign. Because whatever's on this side is going to have to equal on that side. The products are going to equal the reactants. So we're reacting O2 with a carbon source, in this case ethylene, C2H2. It's going to go on to create X CO2s. X in this case is 2. So 2 CO2s plus, this is going to be our water now. The water gets Y over 2. So Y in this case is 2 again. So 2 over 2 just equals 1. So in this case we're going to get 1 water. So we were comparing these, remember? Methane versus ethylene. Same number. This should be H4. See, I messed it up already. I'm catching myself there. That would have been, it'll still work. Tell you what this actually is C with a triple bond. Acetylene. 1 H, 2 H's. So we'll compare 3 of these. See, we didn't waste our time on that. I thought something was kind of silly on that. So this was a triple bonded C2 between their C2H2. I don't know if we did this right though. For the Y on the top part up here should have been 2, so 2 over 4 was a half. That's what we did, a half. So 2 plus 2 and a half O2s. 2 and a half O2s. You're going to have to double all this. See, this is about as complicated as it gets. So 1 acetylene, triple bonded. Goes on to make 2 CO2s and 1, so we're going to have to get this double to make it 5. So let's just do that in our head. 5 O2s, 2 ethylene groups, acetylene groups. It's got 2 different kinds of names to it. Double that is going to be 4 CO2s plus 2 H2Os. All we have to do is make sure whatever we got on one side, we got on the other. So when you're balancing these equations, the first thing you do is you start with the carbons. Count the carbons on both sides first. So 2 acetylenes, YN, means triple bond. 2 times 2 is 4. We look on this side, we got 4 CO2s, 4 times 1C is 4. Next we do the oxygen. No oxygens here. Here we've got 5 O2s is a total of 10. Here we got 4 CO2s is 8. 2 and the O's in the water is 10. So that works so far. Lastly, H's. We got 2 times 2 is going to be 4. No H's in there. 2 times H2O2. It works. So this little formula here is pretty cool.